Today we'll be doing section 5.8, fractional coefficients. We will be solving equations today, first just with x's and coefficients that are fractional, then we'll be tackling some word problems. So sit down, fasten your seatbelt, let's go. How do we solve equations and inequalities having fractional coefficients? So, to solve an equation or an inequality having fractional coefficients, it is helpful to multiply both sides by the LCD of the fractions, the least common denominator. Yesterday, when we were doing complex fractions, we would multiply the top and bottom by the least common denominator of all the fractions to eliminate the denominators. Today, you will be doing the same thing, except you'll be doing it on both sides of the equal sign. So let's look at example 1. We have x squared over 9 minus x over 6 minus 1/2 equals 0. So most of us don't like dealing with fractions. We like to deal with integers. So with an equation, you can multiply out both sides by the least common denominator of all the fractions. So we have a 9, a 6, and a 2, and we need to find the least common multiple to find the least common denominator. So what is the least common multiple of 2, 6, and 9? Well, if you wanted to do that by hand, you would see that it is 18. So you multiply every term of the equation by 18 on both sides. So 18 times the first term, 18 times the second term, 18 times the third term on the left, and 18 times the 0. Now, you'll want to set it to be 0 on one side so you don't have to worry about multiplying the right side, because anything times 0 is going to be 0. So now you just simplify each term, and you get 2x squared minus 3x minus 9 equals 0. Well, we can solve that. We've been doing that for the last month. So you can use the box method or whatever method that works for you, and you will see that it's 2x plus 3 times x minus 3 equals 0. So x is either equal to negative 3/2 or 3. And don't forget to put your answer in a solution set because we're solving for x. So again, for this problem, look at the denominators, make sure one side of the equation is set to 0, and then multiply every term by the least common multiple of the three denominators. In this case, it's 18. That'll get you integer coefficients, and then you can solve it just like you did before. Example 2, you see the question before you. Go ahead and try to solve the problem on your own. Remember, you are looking for the least common denominator of the three terms. When you're ready to check your work, restart the video. Alright, so the least common multiple is going to be 6, so you're going to want to multiply every term by 6. So you do that, and you get 2 times x plus 1 plus x minus 1 equals 3 times 2x plus 1. Now you distribute and solve for x just like you did back in Algebra 1. So I'm merely distributing the coefficients, combining like terms, and solve for x. And what you see is you get negative 3x equals 2, divide both sides by negative 3, and you get x is equal to negative 2/3. Don't forget to put it in a solution set. So again, just take the equation you have, multiply every term by the least common denominator, that'll cancel out the denominators, and then solve for x. This one doesn't even have a quadratic, you don't even have a factor. So easy. Let's go to number 3. Again, you are using the same approach. Go ahead and try this on your own and see what you come up with. So the least common denominator of 2, 3, 4, and 5, if you actually check it out, is going to be 60. So let's multiply every term by 60. And now let's get rid of the denominators, and you get 12k minus 15k equals 40k minus 90k. And you're going to see very quickly in this problem that 47k is equal to 0. So k is equal to 0. The only possible solution is 0 because you're going to basically have a k in every term, and the only way anything minus anything with the same variable as a term is going to be 0. Now we have an inequality. X minus 14 over 4 is greater than or equal to 5x over 12 minus 3. So you do this problem the same way you do the other ones, just make sure you're careful with the sign in case you multiply or divide by a negative number. So find the least common multiple of 4 and 12. and see what you get. Well, that's an easy one again. The least common multiple of 4 and 12 is just 12, so let's multiply every term in the inequality by 12. And when you're done with that, you get 3 times x minus 14 is greater than or equal to 5x minus 36. Now we just solve for x like we did before. So if you move the x's to the left side and move the integer values to the right, you get negative 2x is greater than or equal to 6. Divide both sides by negative 2. Don't forget to flip the sign. You get x is less than or equal to negative 3. So you plug that into your solution set and you write down your final answer. So with an inequality, you don't treat it any differently than you did an equation. Just remember that when you divide by a negative number, you flip the sign. Last one for the non-word problems. You see it in front of you. Go ahead and try to solve this on your own. So we're looking for the least common multiple of 3 and 7. 3 and 7 both being prime numbers. The least common multiple is just 3 times 7, or 21. So we multiply every term by 21. And you're going to end up with this. 7 times b plus 2 minus 3 times the quantity b minus 2 is greater than or equal to 42. Now you just simplify and you solve the inequality just like you did back in Algebra 1. Let's combine like terms. 4b plus 20 is greater than or equal to 42. Subtract 20 from both sides. You get 4b is greater than or equal to 22. So b is greater than or equal to 11 halves. And there's your answer in a solution set form. Alright, so that takes care of the non-word problems. You need to take a break. It's a good time to do it because we're going to tackle 3 word problems in a moment. Alright, example 6. The German club collected the same amount from each member participating in a trip to a music festival. When 6 members could not attend, each of the remaining members were charged $2 more to cover the total cost of $360. How many members went on the excursion? Alright, so remember the steps to solving these word problems. You need to break it down. So first thing you want to know is, what is the question asking? The question is asking for how many members went. So let's call that x. X is the number of members that are actually going. Now, we have an issue where 6 members could not attend. So we need to know how many of the original members are going. So if we have x number of members going, the number of members that were originally going is x plus 6, because 6 members can no longer go. So originally we had x plus 6 members. Now I wanted to ask you, how much is the total cost of the trip for everyone, no matter how many people go? And the answer is $360. So now we can start setting up an equation using x plus 6, and 360. So let me ask you, how much is paid by each member at the beginning? So you take the number of dollars divided by the number of members at the start, which is 360 divided by x plus 6. Now, with 6 people leaving, does the total amount that they're spending change? It doesn't. So, what is the new amount paid by each member? Well, how many members do we have at the end? We have x, so our new amount paid per member is 360 divided by x. Now, we have to stick the $2 somewhere. Were the members charged $2 more before or after? Well, because people left, they had to pay more after. So we'll take 2 and add it to the original amount. So our equation is 360 over x equals 360 over x plus 6 plus 2. So let me repeat this. We found out how much was paid originally by each member. We had x plus 6 members at the beginning. We have x members that are actually going, so that cost is divided 360 divided by 6. Because they were charged $2 more to cover the cost of those not going, we have to add the 2 to the right side to the original price. So the new price is more than the original price, so we add 2 to the original price. Now we have a problem. We can just solve it just like we did before. And again, you're going to be looking for the least common multiple. What's the least common denominator for this equation? Well, you have an x and an x plus 6. Based on what you did back in the previous section, you know you have to multiply both sides and every term by x and x plus 6. So let's go ahead and do that. You get 360 over x times x plus 6 equals 360 over x plus 6 times x plus 6 plus 2x times x plus 6. Okay, so let's go ahead and simplify this. Let's cancel out the denominators and see what we're left with. We have this after canceling out the x plus 6, and this one we don't have to touch. So now let's distribute and combine like terms and set one side equal to 0 because we have an x squared. So the 360x's nicely disappear. Now I'm going to move the 2160 over to the right side and then divide both sides by 2 to get a singular coefficient of 1 behind the x squared. So you're left with x squared plus 6x minus 1080 equals 0. Alright, so now we'll just factor. You're looking for two numbers that multiply up to negative 1080 but add up to 6. I can tell you that they are negative 30 and 36. So x is either negative 36 or 30. But since you can't have a negative number of people, the number of members going on the excursion is 30. And that's your answer. 30 people are going. So to solve this equation, you just got to make sure you figure out what you're solving for, define your variables, define the relationship by putting them in an equation, and then solving. Let's take a look at number 7. Crane A can unload the container ship in 10 hours, and Crane B can unload it in 14 hours. Crane A started to unload the ship at noon and was joined by Crane B at 2 o'clock. At what time was the unloading job of the ship finished? So you're basically looking to see how long did Crane A work for since it went first. So let's start defining some variables. Now, if I wanted to set a variable to the number of hours A worked, remember that's what we're solving for, let's call that T for time. If A worked for T hours, how many hours did B work? Since B started 2 hours later, it worked for T minus 2 hours. So now we have how long each crane worked. Now the next part is a chart that the book doesn't use, but I think it might actually be helpful. So let's put it together, and the first column is the rate of unloading per hour. So because Crane A can finish the job in 10 hours, it can do 1/10 of the job per hour. Now, since we're looking to see how many hours it worked T, this is a rate times time equals distance time problem. So RT equals D. So let's multiply 1/10 by T, and we get T over 10. And that's the part done by Crane A. Now for B, it goes at a little slower pace, 1/14, but it's worked for a little less time as well, T minus 2. So the part done by Crane B is T minus 2 all over 14. Now the whole job is basically one ship that needs to be unloaded altogether. So to set up an equation for these work problems, you basically add up A plus B and set it equal to 1. And there's your equation. The part done by A plus the part done by B should equal 1 for the entire job. So T over 10 plus T minus 2 over 14 equals 1. Well, if I gave you this equation, you could solve this. So go ahead and solve it and come back to the video when you're ready. The least common multiple is 70, so let's multiply every term by 70. And let's simplify. So you get 7t plus 5t minus 10 equals 70. Let's combine the like terms, and you get 12t equals 80, so t equals 20 over 3, or 6 2/3 hours, which means that's how long Crane A worked for. So the job was completed, since it started at noon, at 6:40 p.m. Alright, number 8. This is a solution mix problem. A nurse wishes to obtain 800 milliliters of a 7% solution of boric acid by mixing 4% and 12% solutions. How much of each should be used? So again, let's make a chart. I'm going to call the amount of 4% solution in milliliters X. Now, what's the concentration of boric acid for this problem? Being 4%, I would say 0.04 or 4%. Now, if you were to multiply 4% and X together, that would get you the number of milliliters of boric acid. So 4% is 0.04, so the milliliters is 0.04x. So That's the 4% solution. Do the same with the 12% solution. Now, if we had a total of 800 milliliters of solution, the amount of 12% solution has to be 800 minus x. We know the concentration of the boric acid for the 12% is 12%, so now we just multiply the two together, and you get 0.12 times 800 minus x. Now, we know the final mix has to have 800 milliliters. We know the final concentration has to be 7%. So we know the final number of milliliters has to be 0.07 times 800. So let's just go through this chart again. X is the number of milliliters of 4%. Since we have X for 4%, we have a total of 800. So 800 minus X is 12%. And you multiply the number of milliliters times the concentration to get the milliliters of boric acid. Now, we add the milliliters of boric acid together to get this. 0.04x plus 0.12 times 800 minus x equals 0.07 800. We're using this column. So you're basically adding the two solutions together. You're trying to generate a concentration of 7%. Now you go ahead and solve for x like you would if you were just given this as an equation. Since we don't like decimals as much as we don't like fractions, let's multiply everything by 100. You get 4x plus 12 times 800 minus x equals 7 times 800. Let's distribute. Go to the next screen. Combine like terms. You get negative 8x equals negative 4,000. X is 500. So we started with 500 milliliters of the 4% solution. 800 minus x is 300. So we started with 300 milliliters of the 12% solution. So for these mixture problems, figure out how many milliliters of solution, multiply it by the concentration, which is given to you as a percentage, and that combined, multiplied together, equals the milliliters of whatever solution you're putting together. For the final concentration, you know it's going to have the total number of milliliters, multiply that by the final concentration, and you're going to get an equation that way. Well, that ends lecture for section 5.8. I know you probably have questions. We'll have plenty of time to practice in class when we return. If you have questions in the meantime, let me know.